So first topic, let me just share the screen. So this is the properties of region of convergence. Clear? The properties of region of convergence, as we all know, region of convergence is the region where the x of z exists. The ROC of x of z consists of, that is the first property, consists of a ring in the z plane centered about the origin. So it will always be in the form of a ring, as we know that this is the formula. X of z is the formula, and there we have the summation n minus infinity to infinity x of n z to the power minus n. It should be absolutely summable. That is what is the condition for ROC. The ROC of the z transform of x of n consists of the values of z for which x of z is absolutely summable. This is the first property. Now coming to the second property. Second property says that the ROC does not contain any poles. As I've already informed to you all that ROC does not contains any pole. Clear? At the pole x of z is infinite and therefore does not converge. This is the reason that why ROC does not contains any poles. At a pole x of z is infinity, okay, and therefore it will not converge. And the third property says that x of n is of finite duration, then ROC is the entire z plane. Okay, ROC is the entire z plane except possibly at z equals to 0 and or z equals to infinity. As we have seen in the previous lecture, अगर x of n आपका finite duration sequence है, so in that case ROC will be the entire z plane except at either z equals to 0 or z equals to infinity, or both. That is, if it is a both-sided finite duration sequence, it will be the entire z plane except at z equals to 0 and z equals to infinity. Okay, so that is the property 3. Now we'll go to the next property. Now these are the just explanation about the properties. Okay, so we can just go through it, that what are the explanations. Now the fourth property. Fourth property states that if x of n is a right-sided sequence, if x of n is a right-sided sequence, and if the circle mod of z equals to, that is the gamma naught, that is if it is a value, certain value is in the ROC. अगर right-sided sequence है तो definitely of infinite duration. We are talking about infinite duration right now, and if it is a right-sided sequence, then in that case, if mod of z is equals to gamma naught is in the ROC, then all the finite values of z for which mod of z greater than gamma naught will also be in the ROC. मतलब suppose if ROC is this region, that is the greater than the value A is the pole at which the ROC, that is from where the ROC is starting, that is mod of z is greater than mod of A. Now like suppose this is the ROC, mod of z is greater than mod of A, and if gamma naught lies somewhere here, now if this is the point where the gamma naught is lying, in that case what will happen, for all the values which are greater than gamma naught, all the values will come in the ROC if it is a right-sided sequence. Okay, so this is the condition for right-sided sequence. Now we can even go for the left-sided sequence, that is if it is a left-sided sequence. Property 5 says that if it is a left-sided sequence, and in that case ROC will definitely mod of z less than mod of A, that is the interior of the circle of radius A, that we have already studied in the previous lecture. Okay, mod of z will be less than mod of A, and if gamma naught lies somewhere here, in that case all the values between 0 to gamma naught of all the values of z between 0 to gamma naught will also be in the region of convergence. Okay, so that is what it is trying to say. This is the fifth property. Now next property is the sixth property. If x of n is two-sided sequence, matlab if it is in the positive n side also and it exists in the negative n side also, then if the circle mod of z equals to gamma naught is in the ROC, agar ye ROC mein hai, then in that case ROC will consist of a ring in the z plane that includes the circle mod of z equals to gamma naught. Now this can be very well explained by this diagram. As we can see, for right sided sequence ROC kya hota hai, mod of z greater than mod of a. Now here a is lying somewhere here, mod of z greater than mod of a, so that is the exterior of the circle of radius a. And for the left sided sequence ROC is mod of z less than mod of b, that is the interior of the circle of radius b. So actually ROC is this region, that is mod of a should be less than mod of z should be less than mod of b, that is a should be less than b. So that is what it is possible only if a is less than b, that is b is greater than a. And if b is less than a, in that case the ROC will not exist and the x of z will not converge. Okay, so this is the region of convergence for two-sided sequence, and if gamma naught is somewhere here, then all the values between a to b will be in the region of convergence. So that was the property 6, and we are done with the properties of the ROC. So we have studied about the properties of the ROC. Now we'll go into the properties of the Z transform. Okay, now we'll start with the properties of the Z transform. Properties of Z transform. Now in the properties of the Z transform, the first property is linearity. Linearity property, it states that if x of n, x1 n has the Z transform x1 z with ROC R1 and x2 n has the Z transform x2 z with ROC R2. ठीक है, so these are the x1n and x2n with the respective ROCs. Then according to the linearity property, a x1n plus b x2n will have Z transform a x1 z plus b x2 z, ठीक है, with ROC R1 intersection R2. Now this one is an important thing that we need to understand कि आपका ROC क्या होगा. ROC will be R1 intersection R2, that is the common intersection means what? The common region among R1 and R2, that is going to be our ROC for the first case. The second property is saying that time shifting. Now in the time shifting properties, if x of n has Z transform x1 z with ROC R1, then x of n minus n naught, that is we are shifting the time n minus n naught if we are taking. In that case, the Z transform would be z to the power minus n naught x of z. That means if it is shifted by n minus n naught, this term will get multiplied to x of z. Okay, and what is this term? X of n z to the power minus n naught. Z to the power minus n naught will get multiplied to x of z. Similarly, if I am writing x of n plus n naught, it will have Z transform z to the power n naught into x of z. ठीक है. So these are the time shifting properties. Multiplication by exponential. Multiplication by exponential, that is, if I am having x of n, z transform, x of z with ROC R, then if I am multiplying a to the power n to x of n, it will have z transform x of z by a. It will have z transform. If I am multiplying this term a to the power n into x of n, it will have z transform x of z by a with ROC, that is mod of a into r. Now here the ROC was r, whatever the r would be. In that case, if I am multiplying e to the power n x n, the z transform will be x of z by a. जो भी a रहेगा, that will become x of z by a, and the ROC will be mod of a into r. Now in this case, a has to be a complex number, provided a is a complex number. ठीक है, तो ये होना बहुत जरूरी है. Then only it is applicable. Clear? So these are the three properties. Now in this one, we can continue with one more thing. That is, if e to the power j omega n, if this one is multiplied to x of n, in that case, the z transform, according to this property, e to the power j omega n is multiplied to x of n, then this becomes x of z by e to the power j omega. ठीक है, and this is x of e to the power minus j omega into z. ठीक है, so that is going to be our conclusion from this property. If I am multiplying e to the power j omega n, that is e to the power j omega is a term, it is multiplied to x of n, then the z transform will be x of z by e to the power j omega. Similarly, if I am multiplying e to the power minus j omega n to x of n, the z transform would be x by x of z by e to the power minus j omega, and this becomes x of e to the power j omega z. ठीक है, so that is the conclusions out of the third property. Now the fourth property. Fourth property is time reversal. Time reversal says if x of n has the z transform x of z, then x of minus n, definitely if it is a time reversal, it will be x of minus n, then it will have z transform x of 1 by z. Now here the ROC was r. Now here the ROC will be 1 by r. ROC is 1 by r. Now this is the important thing to understand. If x of n has z transform x of z, then x of minus n will have z transform x of 1 by z with ROC 1 by r. ठीक है? Now the next property is the time expansion. Time expansion is an important property again. If x of n has z transform x of z with ROC r, then xkn मतलब this has a different meaning. Xkn has a different meaning, and what does it means will tell you. Xkn will have the z transform x of z to the power k, and ROC of this will be r to the power 1 by k. Now this is what we need to understand. Now what is this xkn? Xkn means x of n by k. That is, it is a time scaling. What it is happening here? It is x of n by k time scale हो रहा है. If n is an integer multiple of k, n is an integer multiple of k, or it will be 0 अगर integer multiple नहीं है. If n is an integer multiple of k, in that case it will be x of n by k, and it is 0 otherwise. ठीक है? So this is what x of n by k means. That means we'll have to take x of n by k. If this is the condition, then in that case our z transform will be x of z to the power k. ठीक है? x of z to the power k. This is what it is written here. X of z to the power k. Now the next property. Next property is time expansion was the fifth property. Then we have sixth property which states that multiplication by n by n or differentiation in z domain. This is also called as differentiation in z domain. Now if x of n has z transform x of z, ठीक है, with ROC R, then if I am multiplying n to it, the z transform will be minus z d by dz of x of z, minus z into d by dz of x of z, and the ROC will remain R. ठीक है? ROC will remain R. This is what is called differentiation in Z domain. Multiplication by n will be the differentiation in Z domain. Now next is seventh one is conjugation property. Conjugation property states that if x of n has Z transform x of Z with ROC R, then x conjugate n will have Z transform x conjugate Z conjugate, ठीक है, with ROC still R, ठीक है. So if we are taking x conjugate n, मतलब अगर x of n is a complex, then if we are taking x conjugate n, then the Z transform will be, this one is capital X, ठीक है, capital X का conjugate, capital X का conjugate with Z conjugate, ठीक है. So this is the conjugation property. Then we have the convolution. The convolution property states that x1n will have Z transform x1z ROC R1, x2n will have Z transform x2z ROC R2, then x1n convolution x2n will have Z transform. If I am taking the convolution of x1n and x2n, I will have the Z transform, which is x1z into x2z, and the ROC is R1 integration, sorry, R1 intersection R2. ठीक है, R1 intersection R2, that is the common in R1 and R2 will be the ROC of this particular thing. ठीक है, so that is how we can obtain the ROC. These properties are very important to understand, as we will make use of this property for solving the numericals. And for solving numericals, these are very important. We need to understand how the properties work and where we can make use of these properties when solving numericals. 8 properties done, convolution property. Then we have multiplication. ठीक है, now multiplication, similarly we know that if x1n has Z transform x1z, x2n will have Z transform x2z with the ROCs R1 and R2, then in that case we need to just know that x1n into x2n अगर हम लेते हैं, here we have taken convolution of these two sequences x1n and x2n, and we got x1z and x2z, that is multiplication in frequency domain. ठीक है, so here this is multiplication in Z domain. Now this one is, if I am taking multiplication in time domain, then Z transform would be 1 by 2 pi j. 1 by 2 pi j. We have a contour integration. Now this one is a contour integration. Contour integration. Then I am taking x1 v. Now here I am taking v, that is a different variable. I am not taking z here. I am taking v. x1 v and x2 multiplied x2. This is z by v. Okay? And here it is v to the power minus 1 dv. So the variable has been changed here. Here it is 1 by 2 pi j contour integration x1 v into x2 z by v, v to the power minus 1 into dv. So this is how the multiplication is done. Multiplication in time domain will have the Z transform in this particular form. This is also known as complex convolution property. Complex convolution property. Okay? Now the next one is accumulative property. Accumulative property says that if x of n has the Z transform x of z, then summation k minus infinity to infinity x of k. If I am taking x of n in this form, and if I am taking k as a different variable where it is a summation, accumulative मतलब x of n का पूरा मैं ले रही हूँ from minus infinity to plus infinity, then it is x of k and it will have Z transform 1 by 1 minus z to the power minus 1 into x of z. Okay? So the Z transform of this particular function, if I am taking the complete x of k, if x of n has Z transform x of z, then if I am taking the summation k minus infinity to infinity, x of k will have Z transform 1 by 1 minus z to the power minus 1 into x of z. Okay? That is going to be the accumulation property. Then we have Parsevals. Parsevals theorem. Now this is the combination of 2-3 properties here. If x1n has Z transform x1z and x2n has Z transform x2z. Okay? Then according to the Parsevals theorem, if I am taking summation if I'm taking summation n minus infinity to infinity x1n x2 conjugate n, ठीक है, x1n x2 conjugate n, this is equals to 1 by 2 pi j x1n x2 conjugate n, मतलब ये वाला चीज आ रहा है x1n और x2n, तो यहाँ पर x2n has been taken in terms of conjugate, यहाँ पर conjugate ले लिया, so that is what we'll make use of 1 by 2 pi j, again we'll take contour integration, ठीक है, contour integration. Now what would be my first term? This will be x1 z into x2 conjugate z, ठीक है, and we have the term z conjugate to the power -1, ठीक है, z conjugate to the power -1, मतलब this one ये आपका रहेगा, ये conjugate है, we have studied about the conjugate, this will be x of x2z है, जहाँ पर this will be the z conjugate, so I'll have to write it in this way, x conjugate z conjugate हो जाएगा ये, ठीक है, this will be z conjugate to the power -1 into z to the power -1 dz. This is going to be the entire integration, contour integration, that is 1 by 2 pi j contour integration x1z x2 conjugate. Now here it is z conjugate to the power -1 z -1 dz. ठीक है, this is what is our Parsevals. Definitely x1n and x2n has to be a complex variable, ठीक है, complex number. Now the next is the initial value theorem. For the next one is, this is the 11th one. 12th is the initial value theorem. Then we have final value theorem. So we will be done with the properties of this also. Z-transform. Let's see what does the initial value theorem and the final value theorem states. Is initial value theorem, ठीक है. Now initial value theorem that is used to obtain the initial value of x of n. हमें x of n का initial value निकालना है. For that purpose we make use of this property. For a causal signal, causal sequence मतलब which exists only for positive value of n. If x of n has the z transform x of z, if x of n has the z transform x of z, in that case then if I am taking limit n tends to 0, n tends to 0, x of n will be equals to x of 0. Definitely, if I am taking n tends to 0, x of n will be x of 0, and this is equals to limit z tends to infinity x of z. Limit z tends to infinity x of z. Now this theorem helps to find the initial value of xn. Initial value of xn, x of 0 is nothing but the initial value of xn from x of z, from x of z z without taking its inverse z transform. Without taking its inverse Z transform. Now this is an important thing that we don't have to go into the inverse Z transform to obtain the initial value of x of n. We can directly apply limit z tends to infinity to x of z and we can obtain the x of 0. Okay? So that is what is the initial value theorem. Now coming to the next one, final value theorem. Now final value theorem states that this is again for a causal sequence. Causal sequence, if x of n has z transform x of z, x of n has z transform x of z, and if the condition is if x of z has no poles outside the unit circle. X of z has no poles outside the unit circle and it has no double or higher order poles on the unit circle centered at the origin. Centered at the origin of the z plane. Okay? Now this we need to understand कि f of z has no poles. अगर वो बोल रहा है कि x of z में कोई pole नहीं है outside the unit circle. Unit circle के बाहर there is no pole and it has no double or higher order poles. Double or higher order poles भी exist नहीं करते हैं on the unit circle centered at origin of the z plane. Now this is the condition for this. ठीक है? If this is the condition, then limit n tends to infinity of x of n will be x of infinite. X of infinite is limit z tends to 1 z minus 1 into x of z. Okay? So this we need to know. If for final value theorem, if we have to obtain x of infinity, that is a steady state value. This one is nothing but a steady state value. Limit n tends to infinity for x of n equals to x of infinity. This will be equals to limit z tends to 1, where it is z minus 1 into x of z. Okay? Z minus 1 into x of z, and this theorem enables us to find out, the steady state value, of x of n. X of n, that is x of infinity. Steady state value of x of n is x of infinity without taking the inverse z transform, without taking the inverse z transform of x of z. Okay? Without taking the inverse z transform of x of Z. Now these are the two important theorems that is again used while solving the numericals. So this one is the initial value theorem, and then we are having a final value theorem. Now we'll solve few of the numericals based on this. Using the properties of Z-transform, find out Z-transform of the sequence x of n equals to u of minus n plus 1. ठीक है, that is given x of n equals to u of minus n plus 1. Now u of minus n plus 1 will make use of कौन सी property? Will make use of time reversal, because it is u of minus n है, तो minus n definitely will have to use time reversal. Then it is u of minus n plus 1, definitely we again will have to make use of what? That is the time shifting. So we'll make use of both the properties, time reversal and time shifting. Now this can be written as u of minus is taken out, this becomes n plus n minus 1. ठीक है, this becomes u of minus is taken out, n of minus 1. Now using, see we have to mention always कि कौन सी properties हम use कर रहे हैं. Using time reversal and time shifting. ठीक है, हम टाइम रिवर्सल एंड टाइम शिफ्टिंग प्रॉपर्टीज यूज कर रहे हैं, where x of minus n has the z transform. What is x of minus n? It is x of 1 by z. We already know this. X of n has z transform x of z. Then if you are taking x of minus n, it will have z transform x of 1 by z. And x of n minus n naught will have z transform z to the power minus n naught x of z. ठीक है, now these are the two properties that will have to use. X of minus n will have z transform x of 1 by z. X of n minus n naught will have z transform x of z to the power minus n naught into x of z. We know that what do we know? We know that u of n has z transform z by z minus 1. This we have already obtained in previous lectures. U of n has z transform z by z minus 1. Now in this, first of all we'll apply time shifting. ठीक है, हम इसमें time shifting apply करेंगे. Then we will apply both this together. That is n minus n naught also and time shifting also. ठीक है, so if I am taking hence z transform of u of minus n minus 1, that is what is our function minus n minus 1. If this is our x of z, this is our x of z, ये हमारा x of z है. ठीक है, so in this one we'll have this one and 1 by z. Z x of z का 1 by z हो जाएगा और ये टर्म मल्टीप्लाई हो जाएगा. That means it will have z transform. If this is getting multiplied, z to the power minus n naught, मतलब z to the power minus 1 into x of z जो है वो x of 1 by z हो जाएगा. Now this is my x of z. This becomes 1 by z minus 1. ठीक है, so this is going to be multiplied, and now since this is my x of z, so x of z is replaced by x of 1 by z. So I'm applying both together. दोनों एक साथ ही मैंने अप्लाई कर दिया है. I've taken the time reversal as well as time shifting. ठीक है. So this gets multiplied according to the time shifting. Z to the power minus n naught gets multiplied. This becomes Z to the power minus 1. Now according to the time reversal, this is x of 1 by z. Now this is my x of z. Wherever I am having z, that will be x of 1 by z. Now if I solve this one, u of minus n plus 1 will have z transform 1 by z 1 minus z. ठीक है. So after solving this, you can easily obtain. Now this is how we make use of the properties to solve both. ठीक है. Now the second question, if my x of n is 2 to the power n u of n minus 2. Now 2 to the power n u of n minus 2, this is the question where we make use of the property, कौन सी property? Multiplication by exponential, a to the power n xn. तो वहां पर हम ये property use करेंगे, multiplication with exponential, using multiplication with exponential. ठीक है. What is it? क्या था property? A to the power n into x of n will have z transform x of z by a. ठीक है. Will have z transform x of z by a. Now since we know that u of n has z transform this one, this ये तो हमें हमेशा याद रखना है. u of n will have z transform this one. अगर इसमें हम u of n minus 2 करते हैं, that is what do we want actually? u of n minus 2. Then u of n minus 2 will have z transform, n minus 2 will have z to the power minus 2 into what? We are having x of z as this one, z by z minus 1. ठीक है. So this will be z to the power minus 2 into z by z minus 1. Now we have to multiply a to the power n, that is 2 to the power n. Now if we solve this one, this becomes 1 by z into z minus 1. यही होगा. z to the power minus 1 is z to the power minus 2 into z है, so this becomes z to the power minus 1. So this is 1 by z into z minus 1. Now what we'll have to do? We'll have to multiply 2 to the power n, this one, to u of n minus 2. To the power n, u of n minus 2 will have z transform. What is it? x of z by 2. तो जहाँ पर z है वहाँ पर वो z by 2 हो जाए. This will become 1 by z by 2 into z by 2 minus 1. ठीक है. This is z by 2 into z by 2 minus 1, or we can even write it as 4 by z minus 2. ठीक है. So this is how the z transform of this particular sequence can be obtained by making use of the properties. Now let us go into the another one, third one. If x of n is alpha to the power n minus 2 u of n minus 2. Now here alpha is also n minus 2, u of n minus 2. दोनों आपका n minus 2 हो रहा है. Now again he will make use of what? Time shifting property हम लगाएंगे यहाँ पर और alpha भी लगाएंगे. Now we know that if it is just alpha to the power n u n अगर होता तो this would have been z by z minus alpha. ठीक है. This would have been z by z minus alpha. ठीक है. अगर alpha to the power n u n होता. Now इसी में हम टाइम शिफ्टिंग लगाएंगे using time shifting. Now using time shifting, that is u of n minus n naught will have z transform. What is it? Z to the power minus n naught x of z. ठीक है. So we'll apply u of n minus, what do we want? N minus 2. So here it is alpha to the power n minus 2 u of n minus 2. This will get multiplied is z to the power minus 2. Now what is my x of z? X of z is this one. into z by z minus alpha. So basically the answer will be 1 by z into z minus alpha. Okay? So this is how this can be solved. Now let us solve just one more question. If x of n is 2 into 3 to the power n u of minus n, ठीक है? Now what is u of minus n? u of minus n क्या होगा? We know that u of n is what? It is u of n is what? Z by z minus 1. It is z by z minus 1. This we already know. मतलब u of n का z transform. The z transform of u of n is this. Now if we are taking u of minus n, तो इसका z transform क्या हो जाएगा? That will become 1 by z. All the z will become 1 by z. This will be 1 by z by 1 by z minus 1. And this will be what? क्या हो जाएगा ये? आपका what is it? It is 1 by 1 minus z. ठीक है? This is u of minus n is 1 by 1 minus z. So in this one, if I am multiplying 3 to the power n, if it is 3 to the power n u of minus n, then अगर मैं 3 to the power n multiply करती हूँ according to this will be z x of z by a. Now what is a here? It is 3. ठीक है? So this becomes 1 by 1 minus z by 3. ठीक है? This is 1 by 1 minus z by 3. And this becomes 3 by 3 minus z. This becomes 3 by 3 minus z. Now we have one more thing to do here. Now if I am taking 2 into u of minus n, it will have z transform. 2 will get multiplied there. That is 2 into 3 by 3 minus z. ठीक है? और even we can write it as 2 by 1 minus z by 3. So that is how we can obtain the z transform of this particular function. ठीक है? So this is how we can solve this one also, and we can obtain the z transform of this function. Now we have the questions based on the final value theorem and the initial value theorem also. I'll just give you a brief of it, that how to solve those questions. ठीक है? Final value theorem or initial value theorem, because those questions are very very important to solve. Now if x of, the question may be of the form find x of infinity. X of infinity, that is, we'll have to make use of final value theorem. If x of z is given as z plus 2 by 4, z minus 1, z plus 0.7. Now we already know what is our x of infinity. This is x of z. X of infinity, it is limit z tends to 1 into z minus 1 into x of z. Limit z tends to 1, z minus 1 into x of z. Now if I am applying this one, limit z tends to 1, z minus 1 into what is my x of z? This one. This is z plus 2 by 4, z minus 1, z plus 0.7. Now I am having z minus 1 here also and in the denominator also, so that will definitely get cancelled out. Wherever the z is there, we can just apply this value, z tends to 1, and the answer of this will be x of infinity, if I'm applying z as 1 in this particular thing, it will come out to be 3. This is 1, 3 by 6.8, and x of infinite value will be just 0.44. So we just have to apply the formula. This is the formula, and we should just remember this formula to obtain the steady state value. Now you may even get the question where the denominator is not in z minus 1 form. So in that case, you will have to bring it in z minus 1 form so that this gets cancelled out. Otherwise, this will be definitely z tends to 1, it will be 0. It will come to as 0. ठीक है, the answer will be 0 अगर ये यहाँ पर ये और ये cancel out नहीं होता है तो. So you have to bring it into this form so that the denominator should have z minus 1 term in it. ठीक है, so that it gets cancelled out, and finally just put the values of z as 1 in the entire term, and then we'll get the answer. Similarly, if we have the question to obtain the x of 0, अगर हमें x of 0 obtain करना है, so in that case x of z will be given to us, and what is the formula to obtain the x of 0? That is limit z tends to infinity x of z. Now z tends to infinity है, that means the entire term should have z in the denominator. अगर denominator में है z तो that will become 0, so that is okay, but if it is in the numerator it will be completely of the form infinite. ठीक है, जैसे suppose if I am having x of z, x of z as z square plus 2z plus 5 by z plus 1 into z plus 0.5. Now this one I can write it completely. इसको मैं पूरा divide कर सकती हूँ dividing by z square. Completely if I divide it by z square, the numerator and the denominator, this will be 1 plus 2 by z plus 5 by z square. ठीक है, and in the denominator also if I divide it, it will be 1 plus 1 by z, 1 plus 0.5 by z. ठीक है, now this can be my x of z. Now here if I apply the limit z tends to infinity, this term will be 0, this term will be 0, this term will be 0, and this term will be 0, and the rest of the thing that I can write the answer. And here my x of 0, now this is nothing but the x of 0, and accordingly I'll get my x of 0. If I solve this one, this will be just 1, because this is 0, this is 0, this one is 0, and this one is 0. So all the terms which are having z in the denominator will become 0 after applying limit z tends to infinity, and this will become 1. चलो ठीक